Okay, very quickly, two assumptions. One is that there should be some variability in X. Okay, I'll give you an example, a graphical example. Supposedly, if you have two observations like this, very, very near to each other, though they look like in horizontal ways, supposedly these are very near to each other. Can you draw a line out of this? Will the line be like this? Or will the line be like this? Or will the line be like this? I don't know. Could be anything. Don't know what would be the slope. You don't know. I don't know what is going to be the regression line. So in case if all the x's are same, I cannot say what would be the line. Okay, I cannot say what is actually causing the variability in y. If everyone has the same educational level, everyone in your data, and if many of them have different income levels, then what will you say that what is actually affecting these income levels? You have only one variable in your model, okay, say education, and everyone has the same education, and corresponding to those everyone, you have the different income levels. So what is explaining the variability in these income levels when everyone has the same education level? You don't know. Okay, so you need some of the x's to be different. That will explain some variability at least. While in case, if you have something like this, some variability, you can say what would be at least roughly the regression line. Supposedly this, then again you can say roughly what is going to be the regression line. Or like this, again you could say what would be roughly the variability in X. Okay, so you need at least some of the x's to be different. Some of the x's to be different, otherwise you cannot estimate the regression line. Okay, we'll go in detail about this in the course. Then there is one more assumption which is left, which is no perfect multicollinearity. Okay, I'll not talk in detail about perfect multicollinearity and all that. There should not be, assumingly that these variables, these independent variables are actually independent. Okay, in case if these two variables are related with each other, x2 and x3 are related with each other, okay, then, and there is some variability in y, how can you explain that what is causing the variability in y? Is it x2? Is it x3? You don't know. You cannot separate out the effects of x2 and x3 on y. Okay, so you cannot say. So in case if the correlation is not equal to 0, you cannot separate out the effects of x2 and x3 on y. So you will not want such a case to happen. Okay, it will have the effect on the standard errors. Okay, it will have the effect on t statistics and so on. So we'll be talking about in detail again. So these recordings, I must say that please go, whosoever is listening to all of these recordings, please go through these recordings one by one to get a clear idea about the course. Okay, we'll be talking in detail about all of these assumptions and what will happen in case if you drop these assumptions. What will happen to the estimates? Will the estimates be unbiased? Will the estimates be consistent? Will the estimates be efficient? And in case of these problems are persisting, how do you correct these problems? First is that how do you identify these problems? And then how do you correct these problems? Okay.